Hey everyone, this is our lesson on electric current and Ohm's law. So by the end of this lesson, you should be able to summarize static and current electricity. So this kind of builds off what we learned in the previous lesson. So first, let's talk about potential difference, and this deals with potential energy, which we've learned about through this semester. So the difference in potential energy causes electrons to flow from places of high potential energy to places of lower potential energy. Remember, things flow from high to low. And the potential difference, which is noted by the letter V and like a calculation, is the difference in potential energy between two places. This is measured in volts, which is why we use a capital V here, also known as your voltage for an object. We measure this with a voltmeter, and the greater the potential energy, the faster the charge will flow to try to equalize out. And when we look at this flow, we can talk about electric current. So a circuit itself, which we'll go into another lesson on circuits, is a closed path through which electrons will flow. And as they flow, we are registering or monitoring the electric current. And this is the flow of electrons through any wire or conductor. So this is noted by the letter I in an equation. And the current itself is the rate at which charge passes at a given point, so wherever you're monitoring it from. This does depend on the number of electrons passing at a given time, so the more electrons you have, the higher the current will be. And this is measured in amperes, so the unit for electric current is capital A. And it's also measured, the piece of equipment is called an ammeter. We also have to understand the topic of resistance, which is the opposition to the flow of electrons. So as we're looking for the current through a circuit, we also can have resistors present, which will slow that flow down. And all conductors do have some amount of resistance. Resistance is measured in ohms, which is this omega symbol here. And that is our unit as well. So you could write ohms, you could write the little horseshoe looking omega sign. And resistance does depend on a couple things. So first, it depends on the material that the circuit is made out of, because that could raise or lower the resistance present. And it also depends on the size of the circuit or the wire or the diameter of the wire. So the longer the circuit is, the more resistance will be there as opposed to a short circuit. And the wider it is, the less resistance there will be. And then we said length of the circuit as well. Temperature of the circuit also will play a factor, because warmer temperatures tend to have more resistance because the particles within the material of the wire are able to vibrate more, which could then interfere with the flow of the electrons. So now let's talk quickly about Ohm's law, which is the calculation that you need to know for this unit. So this states that the current in a wire is equal to the voltage divided by the resistance in that circuit. And this identifies the relationship among current, voltage, and resistance. So since voltage and resistance are divided here, it's a direct relationship. So as one goes up, the other goes up. And then the greater the potential difference or voltage in a circuit will cause the electric current to increase. Okay. So now let's look at this example here. So it says, what current flows through a conductor having a resistance of 84 ohms, that's a misprint, ohms, connected across a 12-volt battery. So we know we have a resistance of 84 ohms. We know we have a voltage of 12 volts, but we're looking for the current. Remember, our calculation is I is equal to V over R. So we're going to take 12 volts divided by 84 ohms, and we're going to come out with 0.14 amperes. So a volt per ohm is also another way to write your amperes here. So I'm going to cut off my camera and kind of slide that thing to the side so that you can pause your video and try this example.